Hello geometry. So right now we're going to do segment measurements. I know it's pretty hard for you to see the letters, so I just wrote S and T on here. And again, this is how we write segment. Again, we know that we have a bar above it, no arrowheads, and these are the two endpoints. So segment ST is saying you're starting at endpoint S and you're ending at endpoint T, and it's all the points in between it. ST, they're asking, well, what is the distance of ST? How much space is in between them? Well, one way, the easy way, is just count it. So I'm here at -4 and I'm going to 8. If I can see, each of these are going by 2's, so that's 2, 4, 6, 8, 10, 12. So that's 12 units. Now you can also find the difference between them. So I could say 8 minus a -4. And that's going to be my distance. Now remember, distance is always positive. So I'm just going to put the absolute value of it, because when I subtract the 2 points, it doesn't matter if it's positive or negative. It's always going to be a positive number. So 8 minus a -4, remember that double negative means plus. So 8 plus 4, 12. That's 12 units. Now the next part I wanted to talk about is equal versus congruent. Now they're basically the same thing. If they're equal, they're the same. If they're congruent, they're the same. Congruent means the same size, same shape. But normally with this equal, we know the measures. So they're telling me AB is 4 centimeters and BC is 4 centimeters. Well, I know they're the exact same length. I know what that length is. Well, here when they tell me that triangle ABC is isosceles, if we go back to prior knowledge, we know that an isosceles triangle has 2 equal sides, 2 congruent sides. Well, I don't know the size of AB, and I don't know the size of BC, but I know they're equal. I know they're congruent. So that's how I mark congruent. So I think that's just important to know, because we're going to be using that symbol a lot. So when you have markings on your sides or segments or whatever like this, that means that they are congruent. We also should know the symbol for congruent. This is my symbol for congruent. Okay? So I could say segment AB is congruent to segment BC. Okay. Now here's some key vocabulary right here again. Midpoint. So midpoint sounds exactly like what it is. It's the point in the middle of the segment. So the point that divides a segment into 2 congruent segments. And again, that's my symbol. That is my midpoint. So here they're saying, well, let's draw a picture of it. A is the midpoint of CT, segment CT. So I know that one endpoint is here at C, the other endpoint is here at T. That's my segment CT. Well, if A is the midpoint, it's going to be right there in the middle. So I'm going to put a point right there in the middle, and I know that's A. Now, how can I show you that it's midpoint? Well, I can mark the 2 segments that are divided into 2 congruent parts. I can mark them congruent. So now I can say that CA is congruent to AT by the definition of the midpoint. So if A is in the middle, CA has to be equal to AT. Segment bisector. Well, segment bisector, to bisect is cutting it in half. It's splitting it in half. So anything that intersects your segment at the midpoint will be a segment bisector. So it says a point, line, or ray that, and I'm going to say, intersects a segment at its midpoint. That's a segment bisector. So again, here's an example. If we remember, I have a bar up here with only one arrowhead. The arrowhead is always going to the right. So that's telling me this is a ray. KE is a ray. So ray KE is the segment bisector of segment JO. So again, I'm going to draw my segment JO. Those are the endpoints. And if KE is a segment bisector, that means right here where my midpoint is, that's going to have to be where my ray is. I can draw my ray in any direction. I'm going to draw it this way. Well, how we name a ray is important. K has to be the end of the ray. So that means this point right here has to be K. And then this is E. So that's the image of KE bisecting, ray KE bisecting JO. So now we'll do a couple problems. Here they're telling me O is the midpoint of DG. So I know DO is equal to 6x minus 7 and OG is equal to 5x plus 5. So this is my image. By O being the midpoint, they're telling me that DO is congruent to OG. So I'm going to mark that on there. They're also telling me that DO is 6x minus 7. OG is 5x plus 1. So I need to find DG. Well, the only thing I know right now is that these two are equal. So geometry is about relationships a lot. So knowing that these two are equal, I can set up an equation. I can say that 6x minus 7 equals 5x plus 1. And then I can solve that. Solve it, I'll draw my line. I'll get my variable to one side. Got to do the opposite. So I'm subtracting 5x. X minus 7 equals 1, because that canceled out. Then I'm going to add 7 to both sides. Again, I got to do the opposite. This cancels out. X equals 8. So X equals 8. I didn't solve the question yet, though, because they didn't just ask me what X was equal to. They asked me what DG was. So I know DG is this whole segment. Well, if DO is 6x minus 7, I can plug 8 in for X. And I can evaluate that. 6 times 8 is 48, minus 7, that's 41. So I know that DO is equal to 41. Well, if DO is 41, since they're congruent, I should know that OG is 41 as well. If I plug 8 in there, 4 times 8 is 40, plus 1, 41, it works out. So OG is 41. Again, I haven't answered my question because they asked me what DG was. I know this plus this would be DG. So I can say 41 plus 41, 82. So DG is 82. Now we'll turn to the back. On the back, I'm doing the same thing, similar where we're finding midpoint and distance. The only thing is, now we're using the coordinate plane. So with our coordinate plane, we're going to have to graph it. That's why it's the coordinate geometry. We're graphing it. So again, if a reminder, if I'm graphing A, I start at my origin. So if it says -5, 3, again, this is my X and this is my Y, alphabetical order. This is my X-axis and this is my Y-axis. So from the origin, they're telling me go -5, so that's -5 in the negative direction, so to the left, and then +3, which would be up 3. So from my origin, I go to the left 5, 1, 2, 3, 4, 5, and then up 3. 1, 2, 3. So this is where A is. And then B is -1, 3. So again, I need to go to the left 1, and then up 3. 1, 2, 3. So that's B. So if I can look and see, ooh, this one is easy because it's just a horizontal line. So I can just look at this and I can see where that midpoint is. So the midpoint will be in between these two, and this right here is that point right there in the middle. I can see I have equal space in between them. So now I just got to find out the coordinates of that point. So from my origin, I see I go 1, 2, 3 to the left, which is a -3. And then I go 1, 2, 3. up 3, which is a positive 3. So my midpoint, M, equals negative 3, 3. To find the distance, again, your distance is just the space in between the 2 points. So let's count that space. 1, 2, 3, 4. It's 4 units. So your distance is 4 units. So when it's a horizontal line like that, and that's extremely easy to see and count and stuff, see and count it. That's an easy way of doing it. But it's not always going to be that easy. And so here's an example where it's not that easy. So first thing I'm going to do is I'm going to plot the points they gave me. So C is at negative 6, negative 5. So I go to the left 6, 1, 2, 3, 4, 5, 6, and down 5. 1, 2, 3, 4, 5. That's point C. And D is at 7, 3. So I go to the right 7. 1, 2, 3, 4, 5, 6, 7.
Spring High School.
So here's 7. And then we had to go up 3. 1, 2, 3. And that's point D. So now I'm going to draw a line. It's best when you make a line to use some type of straight edge so your line is as basically as even as possible. So now I want to find a midpoint. Well, this one isn't so easy to find. I guess I can like estimate where I think that midpoint would be. Maybe somewhere over here, but I'm not 100% sure. The distance is not as easy to count either. So here, this is when we might want to use a formula. And this is when the formulas are important. So sometimes it might be easier to use the formulas if it's not as easy to find, or the points are very far apart, that might take a lot of time or whatever. So my midpoint, that is just the average of my 2 points. So we go here, M, which is midpoint, that's the average of the points. So if I add my 2 x's together, x1 plus x2, and divide them by 2, since there's 2 of them, that gives me the average of them. That's going to be the middle of those 2 points. That's going to give me my x variable. I do the same thing for my y's. I add the 2 together, divided by 2. That's finding the average. And that's going to be my y coordinates. So that's how we find midpoint. And this is actually a really easy formula. So again, if we look at our coordinates, it doesn't matter. I'm just going to say the first one we name is going to be x1, y1. So the first point you name can be x1 and y1. The second one you name would be x2, y2. And then you just plug it into the formula. So my formula tells me, okay, I need to take my 2 x's and add them. So that's going to be negative 6 plus 7 divided by 2. That's going to be the x coordinates. Do the same thing to the y. Negative 5 plus 3 divided by 2. And that's going to give me my y. So if I evaluate that, negative 6 plus 7, that's a positive 1. 1 over 2, 1/2. Negative 5 plus 3, that's a negative 2, I'm sorry. Negative 2 divided by 2, negative 1. So my midpoint is at 1/2, negative 1. So if I graph that, I got to go halfway down and then here at negative 1. So that's where the midpoint of the line is. So it's about where we said. So that's my midpoint. So again, to find that, you add the average of your x's. x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now to find the distance. There's many ways we can find it. One of the easier way, if I have this image here, if I'm using a graph, is I can just think of the Pythagorean Theorem. So I'm going to make this into a right triangle. So I'm just drawing this horizontal and vertical line from my points, and I just made a right triangle. Now with this right triangle, I know I can use my Pythagorean Theorem to find length CD. So now I gotta see, okay, well, how long is it, this space right here? 1, 2, 3, 4, 5, 6, 7, 8. 8 units. And how long is this space here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 units. Well, Pythagorean Theorem says to find the hypotenuse, I do a squared plus b squared equals c squared. Again, we've learned this before in another class. So a can be 8, so 8 squared, plus b can be 13, 13 squared, equals c squared. 8 squared is 64, 13 squared is 169, equals c squared. 64 plus 169, 233. I don't want to know what c squared is. I want to know what c is. So again, the opposite of squaring something is the square root. So c is equal to the square root of 233. And that's my answer. Square root of 233. Now, I can also put that in a calculator and see what that is. That should be about 15.26. Okay, so that's one way. Make it into a triangle and do the Pythagorean Theorem. But again, you may not always have the graph. You might just have the points. Sometimes those points might be so far away that you don't feel like counting all of those spaces. So what you can do then is use your distance formula. So my distance formula, it seems complicated, scary looking, but it's not really. Distance is equal to the square root of the difference of your x's. So x2 minus x1 squared plus y2 minus y1 squared. So this is my formula for distance. Okay? So again, if we have our points already labeled, I will plug these in there. So I'm starting with x2 minus x1, 7 minus -6 squared plus, and then y2 minus y1, 3 minus -5 squared. So 7 minus -6 squared plus 3 minus -5 squared. And I'm going to just rewrite it over here where there's room. Now, if you remember, minus a negative means plus. So 7 plus 6, that's 13. So 13 squared plus 3 plus 5, that's 8. 8 squared. Now, again, if you see, those are the numbers we had here. So again, that's just finding the distance between those 2 points. That's 169 plus 64, 233. Again, this whole time, we were still taking the square root of it. So the square root of 233, like we said, 15.26. So that's how I find distance. So now, I would like you to try to do this problem on your own. We'll check it tomorrow during our warm-up. Thank you.